हाँ जी.
Yes, sir.
See, if I'm not getting response, you people, na, then you have to turn on your cameras throughout the class. Otherwise, turn on your mic and be responsive. See, you have nearly means you have not done your homework, and when I'm solving homework in the class, you still not responding. So this will not work. Okay. So Jaslin, Jovita, Alina, Abir, Ali.
Yes, sir.
Yes, sir.
So have you understood what I have written?
Yes, sir.
Ali?
Yes, sir.
तो बोलो ना यार, yes, no, when I'm saying that, have you understood? Tell me yes or no. No problem. I will repeat or will explain that how this came. So just respond or otherwise turn on your cameras. So, so KP, we by using this direct formula, we got this KP and its value is given as 2.5 into 10 to the power of 10. Okay. Now, what we have to find? This is the first question. We have to find KP for this. The only difference we see here is this whole equation has been divided by what? Alina,
Yes, sir.
what is the difference between this equation and this equation? In the question given, this equation, this is the question, and this equation. What is the
Two.
difference? Huh?
2.
No, whole equation. The whole equation has been divided by 2, right?
Yes, sir.
So if we write Kp for this, let's see. So partial pressure of SO2. Sorry, this one is SO2. And X. Partial pressure of SO3. Okay. Partial pressure of SO2 with no power. Partial pressure of O2. Ali, what should be the power here on the partial pressure of O2?
One by two.
Ali, 1 by 2. Huh? So 1 by 2. So what we see here is when the equation has been divided by 2, this or we can say this when you do root of this, means take a square root of this, then this equation will become right. Or you just square this, like for example, if you take a square of this whole equation, both side, squaring both side, this equation will become right.
Yes, sir.
Yes.
So through this minor calculation, what we will see here is that when we are taking square root of this, sorry, एक second. When we take square root of it, in another words, when we take square root of this equation will become right. The equation will be this one.
Yes, sir.
Yes, sir.
Anna. So directly without solving much, we can say in the first one, this will be the final answer. Right? Got it or not?
Yes, sir.
In the third one also, what we see here is the whole equation is divided by 2 and multiplied by 3. The whole equation is divided by 2 and multiplied by 3, right?
Yes, sir.
So we can apply that also. In this equation, the equation has been reversed. Can you see? These two equation are reverse of itself. The reactants has been become product and the product has become reactant, right?
Yes, sir.
So what will happen? We will just put inverse of it, 1 upon Kp. When we will do this, this will become reactant and sorry, this will become product and this will become reactant. Then you will get the answer, right?
Yes, sir.
Mm. So there are some after knowing the equations, you have to go through some mathematical calculations. That is it, and you can solve the questions. Please try the this question, the another question, this one. Please try this question. See, let me solve it for you. So here what is happening is, for the formation of NH3 from N2 and H2. So first of all, we have to write the equation, chemical equation of it. N2 plus H2 is giving NH3. Sorry, this is in equilibrium. So we will draw this one, this arrow. And what it is becoming NH3. After writing the chemical equation, we have to balance it. So we will balance it like this. So what the question says, for the formation of NH3 and N2H2, the following concentration were obtained at equilibrium at 500 Kelvin. So at equilibrium, the concentration is given for N2, H2 and NH3. This concentration is also given. This concentration is also given. This concentration is also given. What we have to find out? We have to find out the equilibrium constant. So equilibrium constant is we have to find out. We have to find this Kc. For Kc, we know the formula. Jaslin, what is the formula for Kc? What should be the power of this NH3 here? Jaslin? Alina?
Yes, sir.
What should be the power of this NH3? The power you can see from the stoichiometric coefficient, okay?
Yes, sir.
So this will be 2. What should be the power of nitrogen?
2.
So can you see 2 here?
No, sir.
So what should be the power?
0.
It is 1 here, okay?
1.
What should be the power of hydrogen here?
3.
3, correct. So just after writing this, you have to put the values of this. NH3, we will put the value of this 1.2 in 10 to the power minus 2. Okay, let me just write it for you in a minute. 1.2 into 10 to the power of minus 2, and you have to keep a square of it. Then N2 concentration is 1.5 into 10 to the power of minus 2, and there is nothing we have to do. And for hydrogen, 3 into 10 to the power of minus 2 whole power of 3. You have to just solve this equation and you will get the answer. Okay, it will be like 1.2 into 1.2 into 10 to the power of minus 4 upon 1.5. Just we will open the bracket. 3 into 3 into 3. I'm not multiplying it so that we can divide this numerator versus denominator easily. Minus 6. So now you can solve this, right? Everyone, बोलो भाई.
Yes, sir.
So -6 -2, this will be -8. -8 will go upper side, so it will become +4. Then you just divide them. Okay, so you will get the answer. Got it, everyone?
Yes, sir.
Jocelyn, your answer was correct. Uh, please solve this question. At least solve this question. The question, I'm explaining the question. You will have time to solve this. The value of kp it is asking. Okay, no, sorry. The value of kp is given 1.8 into 10 to the power of -2 bar, and the temperature is given. Equation is also given. We have to find the kc. Okay.
Okay, sir.
Uh, can anybody guess which formula we should use? Anyone? You can message in the chat also. Which formula can be applied here? Hmm? Are you trying, people?
Yes, sir. 1 second.
Which formula we are going to use?
Sir, I sent it.
Correct. So just apply this formula. I want answers from you people. Kp is equal to Kc RT power delta Ng. We have solved some questions also earlier in this class using this formula. Jovita, can you use this formula? Jovita,
Yes, sir.
can you use this formula?
Yes.
Alina,
Yes.
can you use this formula? Are you familiar with this formula?
Yes.
Okay. So I'm going to solve this problem. Anyone got? Please let me know when your approach was correct. So the value of Kp is given in this formula is 1.8 into 10 to the power of -2. In bar it is given. We have to find Kc. So Kc will be Kc only. What is the value of R? What will be the value of R? Anyone? What should be the value of R? Good, Ali. Aji, what should be the value of Ali? At least you can turn on your mic and say something.
Sir, 0.0821 liters.
See, 0.0. Jesslyn, what is the value of R you have taken?
0.083.
Hmm?
0.083.
0.0831. Ali, you have done a minor mistake. When question is given in bar, then it is taken at 0.0831. In if ATM, then it is taken at 0.0821. Okay.
Sir, I took 821.
So this since this is given in bar na, so you have to take this one 831. Okay.
Okay, sir.
No problem. See, if you have done wrong here, you will, and when I will explain that you got your mistake, then surely you will do correct in exam. Okay. And the people who are not even trying, they will means you can say means उनको हवा नहीं लगेगी. So temperature is given as 500. Obviously, it is in Kelvin, so we don't have to change it. Delta Ng. Jesslyn, what you have taken? Delta Ng?
1.
1. So how we have taken one just for revision sake. Delta Ng is we have to count the number of moles in gaseous state or gaseous moles. So we have gas present in both the products. So it is 2 plus 1. Okay, and count the number of moles in reactant side, gaseous moles. So we have 2 here. So we have to subtract each one from them. So 2 plus 1 is 3. 3 minus 2 is 1. So we will get this 1. Okay. So just we have to solve this, do some mathematical calculation, and that is it. Okay, this will be the value of Kc, right? This was the same approach for you, Ali. You have used the same approach. Hmm? Yes or no?
Yes, sir.
Good. Done copying. Hmm.
1 second, sir.
Okay. There are other questions as well. Let me repeat you in your class that at least give 15 minutes for your homework, or if you don't have 15 minutes, at least give 10 minutes. Read the question, try to solve the question in 1 to 2 minutes. If it is exceeding more than 2 minutes, then leave the question. Your work is done. Okay. No problem. Come in class and discuss with me that what problem you have. Okay. You can use chat box also. You can tell me your problem. We will discuss the solution. For
Thanks,
each
sir.
question, any question you have to copy from means other questions you have to copy. Anyone? Yes or no?
No, sir.
Hmm. There are some good questions as well. Hmm. Like for example, this question. Please read this question. This question is in NCRT. Let me read out to you. Then you will get time to solve this question. So the question says is Kc for the reaction. So reaction is given, okay, and its Kc is given. Okay, equilibrium constant is given, and temperature is also given. Now you have to find out the equilibrium concentration of CO2, H2, CO, and H2O. So every concentration you have to find out carbon monoxide, water, carbon dioxide, and hydrogen at equilibrium. Okay, at equilibrium. And the condition which is given is the more information. If carbon monoxide and water was present initially at the concentration of this, the initial concentration of carbon monoxide and water is given. Okay, you have to find out the equilibrium concentration of each component. Are you getting my point? Yes or no?
Yes, sir.
Understood the question? uh, Jovita, have you understood the question?
Yes.
Alina?
Yes.
So Ali, can you tell me, will the concentration of this CO, carbon monoxide, will increase from 0.1 molar or decrease? This question is for everybody. The initial concentration of CO was this, okay, CO and H2O. So when it will be reaching at equilibrium, okay, so will its concentration increase or decrease? These reactants.
It will decrease.
Jaslin, which point you haven't understood? The question,
So I
right?
don't understand how to do it.
No problem. I will solve it for you, obviously. Who was saying what? Increase or decrease?
Decreases.
And the concentration of product? Hmm? Alina?
Yes, sir.
Initially, it has said that CO2 and H2 were not present. Okay.
Yes.
So tell me, when the equilibrium will be reaching, okay, so will their concentration will increase or decrease? The concentration of carbon dioxide and water. Concentration of carbon dioxide and sorry, this hydrogen will increase or decrease when it will be reaching equilibrium?
Increase.
Increase. Correct. Okay. So I think the basic approach, you people have got the basic approach of it. So let's try to solve this question. So question here is CO and H2O is reacting and it is in equilibrium with CO2 and hydrogen. Obviously, CO and water concentration will decrease by time. Why? Because they will react with each other. Okay. So initially, acha, this question is somewhat similar with this question. Okay. We know the initial concentration. Then we will mark out the change. Then we will comment on what is happening at equilibrium. Okay. And what is its concentration. Got it?
Yes, sir.
So let's see. So initially the concentration of CO and H2O is given. which is 0.1 and 0.1 molar, right? The concentration is already given, है ना? And since this is not given, so this is, we will take it as 0. Okay, bolo bhai.
Okay, sir.
Yes, sir.
What will be the change? It will be minus x, means somewhat it reduces, the concentration will reduce, and 1 mole of CO is forming 1 mole of CO2. So when minus x mole is x mole is exhausted, then x mole will be formed here also. Understood this point,
Yes, sir.
everyone? Yes or no?
Yes, sir.
Then we will see what is happening at equilibrium. So at equilibrium, we have left with 0.1 minus x concentration of carbon monoxide. Similarly, this one, and here we have this. Understood till here? So at equilibrium, concentration is this much, right? Then we the Kc is already given, so we will apply the formula. When Kc is given, obviously we will apply the formula. So what is Kc? Kc is concentration of product. The product here is CO2 and H2 with numerical, which with coefficient 1. So we don't have to write anything power. Then we will write this. Okay. Anybody have any problem? Haji? Yes or
No,
no?
sir.
Okay. So then we will put the values of CO2. CO2 concentration was X, hydrogen concentration was X, and its concentration CO is 0.1 minus X, and H2 concentration is also 0.1 minus X. है ना?
Yes, sir.
Yes, sir.
Kc value is given as 4.24. 4.24 is equal to x square upon 0.1 minus x into 0.1 minus x. So it is like a minus b whole square, so a square minus b square plus a square plus b square minus 2ac. So it is 0.1 square plus x square minus 2 into 0.1 into x. Correct? Now what we will do? We will send all this, this material, to this side, and then we will solve this equation. Can you see quadratic equation is forming?
Yes, sir.
So this will be a quadratic equation. So what you have to do is you have to find the value of x here. So in quadratic equation, you may remember this formula. Have everybody seen this formula?
Yes, sir.
Ali,
Yes, sir.
जो भी था.
Yes, sir.
So through this formula, we will get the value of x. So value of x will be after solving. In board exam, you will not get so much calculation, but expect the unexpected thing. Okay. So we will get the value of x here. So finally, you will get the value of x. The question was asking is, calculate the equilibrium concentration of CO2, H2, CO, and H2O. Okay. So concentration of CO was 0.1 minus x. So 0.1, put the value of x here, 0.067. Okay. Similarly, put the value here. We have got the value of this. So concentration of each and every term we have got it. Right? Have you understood it?
Yes, sir.
Everyone? When we got the value of X, we have got the value of concentration. And this is what it was, the question was asking about concentration, the final concentration at equilibrium of carbon each and every product. So when we got the value of X, we got the concentration of each and every product. Got it, everybody?
Yes, sir.
So you can see the concentration of reactants has been decreased. Obviously they will decrease. Why? Because they will react and form the product. So if you have understood, please note it down and let me know when you are done. Done. Yes or no? बोलो भाई.
Finished, sir.
Yes.
Okay. Please solve this question. Let me introduce question to you. So the question says is we have N2O4. The mass of N2O4 is given. Okay. Then it is placed in 1 liter vessel. Temperature is given and it is allowed to attain equilibrium. So obviously means mass of N2O4 will decrease when it will reach equilibrium. The total pressure at equilibrium. Pressure at equilibrium is given. Okay, this is important thing. Pressure at equilibrium is given. Okay, and what you have to find out? Kc, Kp, and partial pressure at equilibrium. So partial pressure of reactant and product. This is the question you have. This is one of the means very good question. Uh, please, you have time to think on it. So let us try solving this question. So in KC, when we will try to proceed with KC, so KC needs what? Concentration. Concentration of NO2 upon concentration of N2O4. Okay. So concentration of N2O4 is given? No. So what is the concentration? It is moles upon volume. Okay. Moles is also not given. Volume is given 1 liter. So what will be the moles? We have this 13.8 gram. So we can find number of moles here. So number of moles is what? Given mass upon molar mass, right?
Yes, sir.
Molar mass. So when we will find this, we will get the concentration of N2O4, but the concentration of NO2 is not given. So this is you will not get Kc from here. So there is some issue here because concentration of NO2 is not given. If it would be given Kc, sorry, if the concentration of NO2 will be given, then we can find out Kc, right? When we will find out Kc, Kp will be found out how? By applying this formula Kc RT power delta Ng, है ना? But this thing is not given. So this is not the proper approach to solve this question. Okay. We will total pressure at equilibrium is given. So somehow we have got some hint to use Kp thing here. Okay. So for Kp, we will move on for pressure here. Okay. The equilibrium pressure is given. So let's see. And also we have initial pressure also. How? We have the mass of N2O5, N2O4 gas present here. So we will find out pressure created due to this N2O4. So how we will find this? We will use this formula. PV is equal to nRT. Okay. So we will find pressure. We have the volume, which is 1 liter. We have the number of moles. Okay. We have the value of R and we have the value of T. Let's see. P is equal to nRT by V. What is N here? Given mass upon molar mass. So given mass is 13.8. Molar mass is, do you people remember how to find molar mass? Molar mass will be 2 times 14 plus 4 times 16, right? Yes or no? This will be the molar mass. Alina,
Yes, sir.
Yes, sir.
this is the way to find molar mass, right? So this will be 92. Then we will put the value of 92 here. Okay. This is number of moles. Okay. Then we'll put the value of R 0.0831, not 21. Why? Because it is given in bar. If it will be given in ATM, then 0.821. Value of T is 400. Value of volume is 1 liter only. Okay. So when we will solve this, we will get the value of pressure. Okay. When we will solve this, we will get the value of pressure, which is 4.98. 4.98. Okay. 4.98 bar, because we are talking in unit of bar. Have you understood, people?
Yes, sir.
Now we have got the initial pressure of the system. Okay. And we have the equilibrium pressure of the system. Okay. So we are going to relate it, the equilibrium pressure and initial pressure. Acha. We have already done in this question initial concentration and equilibrium concentration. Here we are going to do initial pressure and equilibrium pressure. So let us write the equation first. N2O4 is in equilibrium with NO2. Okay. Then we have initial pressure. Initial pressure. What is the initial pressure? 4.98. Right? 4.98 bar. Right? We have found out this. Understood, everybody?
Yes, sir.
Yes, sir.
Means through this, when we have taken 13.8 gram of N2O4, it was creating a pressure of 4.98 bar. So initial pressure was N2O4 only, and NO2 was not present. So it is 0 bar. Okay. What will be the change? It will be somewhat, X will be gone from here, and 2X will form here, right? With every mole of N2O4, 2 mole of NO2 is forming. Can you understand this? Jesslyn, Ali, Jovita, Alina,
Yes, sir.
follow. With
Yes, sir.
every mole of N2O4, we are getting 2 mole of NO2. Jovita,
Yes, sir.
are you getting this point?
Yes, sir.
Hmm. So we have this change. So this is negative change because this has been reduced, and this is positive change. Okay. So what is happening at equilibrium? At equilibrium, this is the this is the pressure of N2O4, and this is the pressure of NO2, right?
Yes, sir.
See how beautifully we are going to use this pressure at equilibrium. So pressure at equilibrium is given as 9.15 bar. 9.15 bar, correct? Which is equal to what? Summation of this and this, because only two component is present in our system. 4.98 minus X plus 2X. Understood, everybody?
Yes, sir.
Yes, sir.
So 9.15 minus 4.98 is equal to X. So from here we will get X is equal to 4.1X bar, the value of X. है कि नहीं? Then what we will do? We will apply this formula, the last step which we are going to use to solve this. So value of Kp is what? Pressure of NO2 upon N2O2, N2O4, I think. N2O4. N2O4. Correct? We will put the values here. 2x square upon 4.98 minus x. So we will solve this here. 4.98 minus 4.17, which will be 0.81. 0.81. Okay. We will use the value, solve this, and we will get the value of Kp. Right? Everyone?
Yes, sir.
Understood or not?
Yes,
Yes,
sir.
sir.
So this will be the value of Kp. We have got the value of Kp. Now simply we will use this formula to get the value of Kc. What is delta Ng here, Ali? Value of delta Ng. Can you tell me? Value of delta Ng. Jovita? Alina? I'm giving you hint, you people. What is the for the value of delta Ng? Can you see where I have written? I don't know. I have given you some example to find delta ng. In delta ng, see, please look on to your this equation in your notebook. Tell me what should be the delta ng. Alina,
Yes, sir.
what should be the value of delta ng? Delta ng is the change in the number of moles of gases. You got the right answer, Ali. Alina, are you understanding or not? Hmm? No, Jaslin. Jobita,
Yes, sir.
what should be the value of delta ng?
1.
1. So why you are not responding earlier? I have, called out you 2 times. Alina, how it is 1? Can you explain? Hmm?
I didn't get.
Okay, so this is the last question we are taking this. So delta ng is change in number of mole in gaseous states. So number of mole in gaseous state is 2 here. Okay, this is the product. And in reactant side, how many number of moles of gas? 1, right? In the stoichiometric coefficient, there is 1, right? Not 0.
Yes, sir.
Correct?
Yes, sir.
Alina,
Yes, sir.
the number of moles you can see here in the product side is 2. Okay?
Yes.
And here you will see 1. Are you seeing 1 here or 0?
One.
No, without mentioning this. What is the stoichiometric coefficient of N2O4?
1.
1. So you have to add all the gaseous, gaseous compound from product side to reactant side. So 2 minus 1 is 1. Okay.
Yes.
So put the value here. The value of R will be, since everything is taken in bar, so it will be 0.031. See, everything is taken in bar. So 0.031. Temperature is already given 400 Kelvin. Just put it in the formula, and you will get the value of Kc. Understood, everybody?
Yes, sir.
Hmm. So this questions is clear to you? Jaslin, you got the na?
Yes, sir.
Huh. So moving on to the next topic, we have already discussed in thermodynamics the relationship between delta G and K. We have used the formula this, and I have told you this will come in this chapter delta. Acha, anyone who wants to note this solution of it?
Yes, sir.
Hmm, please do. एक second. हाँ. These are all NCRT questions. Please do NCRT questions from your side. Okay. And if you have problem, please ask me. Have you people observed? Because we generally we find out Kc, but here we are using Kp. Why? Because pressures are given in the question. So obviously we have to use Kp, not Kc. Let me know when you are done. Done.
Done, sir.
So relationship between delta G and R gives free energy and delta G and K equilibrium constant. So which was delta G is equal to delta G naught K standard gives free energy plus RT ln Q. Q is, everybody know that at equilibrium reaction quotient, which is Q, becomes what? K, right? See, we have done this here. Reaction quotient at when K becomes reaction quotient become equilibrium constant at equilibrium. Okay. So at equilibrium Q becomes K and delta G becomes 0. Why? Because every time at equilibrium, what is happening? Product is becoming forming reactant, and reactant is forming product. So both these both processes are simultaneous. That is why delta G becomes 0. And when we use this in an equation, 0 is equal to delta G naught. Delta G naught is only 0 for uh, pure substances. We have used these terms in thermodynamics. RT ln K, because Q has become K. So delta G naught will be equal to minus RT ln K. Got it? Delta G naught is equal to minus 2.303 RT log base 10 K. So this is the what formula. Okay, you can directly use this formula. We have already done also in that chapter. This one. See this question. We have to find the value of equilibrium constant K. Temperature is given, equation is given, and delta G naught is given. See this formula we have already applied. Delta G naught value we have used the data from the question and use the values and just solve the questions. Okay. Do you remember?
Yes,
Hmm?
sir.
Hmm. So
So your voice is a bit low.
sorry. So this is the log base 10 is done because we have multiplied by 2.303 here. Okay. And this is the final formula. You should remember. So have you understood?
Yes, sir.
Yes, sir.
Done. Noted this thing.
No, sir. One second.
Please do. You have to use the data only to put in here and just use this, solve this equation. Done. Hanji. Done. Hello. Hello. Am I audible?
Yes, sir.
हो गया? अरे हाँ या ना तो बोलो. Yes or no.
Yes.
Okay. So see, now we are going to discuss something like we are taking some examples. Please be attentive here. We are going to start an important topic. Like for example, we have product which is reacting and forming. Sorry, we have a reactant forming a product. Then what is happening? We are taking a case in which case one we have taken in which we have increased the R. Okay, we have added more R. Understand the situation. Reactant is in equilibrium with the product. when it is at equilibrium at the product means now constantly R is becoming product and product is constantly becoming reactant. Okay, and we are not seeing any changes. We have the case one, we have taken that we have increased the concentration of R. We have taken more R from outside and put in the system. Okay, so you have to comment that will the reaction will proceed forward in forward direction or the reaction will proceed in backward direction, meaning that more R will convert into product or product will start forming the reactant. Ali, what do you think? When we increase the concentration of R, the more R will start becoming the product or the product will start becoming the reactant or nothing will happen. Jesslyn, what do you think? Got lots of messages to start working products, so I don't know. Okay, you have to guess. So Ali, your answer is correct. Yes, since they are in equilibrium, what will happen when you will increase the concentration of R? So more and more reactant will start forming the product, and again to achieve the equilibrium, right? When we increase the concentration of R will start reacting with each other, and then it will, because R concentration has increased, so they will try to move forward and become the product, and then again at equilibrium will be achieved. Understood everybody? Understood or not? अरे हाँ या ना तो बोलो, तब मैं कम रिपीट करूं, कुछ बताऊं.
Yes, sir.
So if we increase the reactant, the reaction will move in forward direction. Why it has moved in forward direction again? Why? Because earlier reactant and product are in equilibrium. Reactant concentration has been increased. There are a lot of reactant in the system, so they will start more interaction will start and more collision will start between this reactants, and product will start forming. That is how the reaction has been moved to forward direction. Okay, case 2 will be where we have decreased the reactant. So in this case, what will happen? We have reduced the reactant. So what will happen? Product will start reacting with themselves, and they will somehow manage to, increase the concentration of reactant, because equilibrium has to be established. So product will start reacting with each other, and they will start forming reactant, and again to achieve the equilibrium. Are you getting my point? Hmm? We have decreased the reactants. So if, for example, if the product will be decreased, if product will decrease, can you say that equilibrium will be achieved? the second case is we have decreased the reactant. So if product will decrease, equilibrium can be achieved. Earlier they were in equilibrium. This reactant has been decreased. So let's decrease the product also so that they will be in equilibrium again. To decrease the product, let's start reacting and go in this direction. Okay, then product will decrease, reactant will increase, and again equilibrium will be established. Understood? Yes or no? Yes or no? अरे कुछ तो बोलो कि ये पॉइंट नहीं समझ में आया, ये एग्जैक्टली यहाँ पे मसला है. Say something ना, so that I can understand what problem you are having, or you are having no problem. Is concept clear or everything is clear? Nothing is clear. In chat box I get response from 1, 2, 3 people only. Alina,
Yes, sir.
have you understood or not?
Yes.
Jesslyn, let's see another example. Okay, where we are having a reactant which is in equilibrium with B. Okay, and we are assuming that this is an exothermic reaction. So obviously B converting to A will be endothermic. Okay, because in exothermic B, when A is converting to B, heat is released. Okay, so when heat is given to B, then A is forming. So this is an endothermic reaction. Okay, so for this is the for case for exothermic we are taking the case. So when temperature will increase, then please comment, forward reaction will increase or backward reaction will increase. When we are increasing the temperature, more and more number of A will start forming B, or more and more B will start forming A. Which will temperature increase will be promoted by which one? Okay, let me ask you later. See, when we will increase the temperature, okay, when we are increasing the temperature for exothermic, heat is released. Okay, first let me give example of and temperature is decreased. So for exothermic reaction, temperature is being decreased. So heat will be added. Okay, heat is added from the this side. What do you say? Product side. So we have decreased the temperature. So heat is added in this side, product side. So then forward reaction will promoted. Forward reaction is promoted. Why? Since they are in equilibrium, heat is released at product side. Okay. However, we are decreasing the temperature. So heat will release. This will increase the temperature. That is how they are balanced. When temperature is decreased, equilibrium is, to achieve the equilibrium, let's increase the heat, let's increase the temperature. So for to increase the temperature, we have to move in this direction. Are you getting this? When temperature is decreased, equilibrium is hampered. Now we want to increase the temperature. How temperature can be increased? Let's move in this direction so that more and more heat will released and temperature will be increased.
Okay, sir.
Means everything means the rule is that equilibrium, if anything is in equilibrium, they want to be remain in equilibrium. So the opposite case, when temperature will increase, we have already heat here, so we will move in backward direction. Then backward direction will be promoted. Okay. For endothermic, for endothermic, when temperature is increased, so endothermic reactions love high temperature, right? So when temperature is increased, it will promote forward direction. Anna? And opposite case, when temperature is decreased, mm, reaction will go in backward direction. Got it? So
Yes, sir.
these topics are we are studying under. These are for introduction. This is coming under factors affecting state of equilibrium. State of equilibrium. Like when we are increasing the reactant, so reaction will go in forward direction. When we are decreasing the reactant, reaction will go in backward direction. When we will increase the product, see, when we will increase the product, so the reactant should also increase, so it will move in this direction. When we will decrease the product, reactant should also decrease for equilibrium. So to how this could decrease, let's form more product. Okay, so that is how equilibrium can be achieved. Okay, understood?
Yes, sir.
uh, so the first one is effect of change in concentration. Okay, so like for example, we have reactant, and with reactant what we are doing, we are in first case we have increased the reactant. Okay, and in another case we have decreased the reactant. So in this, if we will increase the reactant, then forward direction forward direction forward direction reaction. And if we will decrease the reactant, since we have decreased the reactant, we should decrease the product also so that it will be in equilibrium. Okay, so backward direction will be promoted. Backward direction reaction. Are you getting this? Hmm? Bolo bhai.
Yes, sir.
Hmm. Let's see another example of temperature which we have seen. Effect of temperature. Again, for example, temperature is temperature is increased. Let's say temperature is increased. So the reaction will shift towards endothermic. Why it will move towards endothermic reaction? Because endothermic reaction wants heat, okay, and we are increasing the temperature, so obviously the reaction will move towards endothermic reaction. If we decrease the temperature, so it will shift towards exothermic reaction. Why? Because heat is already been released, okay, so it will move towards exothermic reaction. Understood, everyone?
Yes.
Hmm. Under for exothermic, let's see, for example, A is converting to B, so this is exothermic reaction. So there is a case like temperature, we are increasing the temperature, okay, so backward reaction is promoted, backward reaction has been increased, okay, so when backward reaction will increase, the concentration of B will decrease, right? So equilibrium, let's comment on equilibrium constant. Equilibrium constant is this. So as concentration of B decreases, equilibrium constant also decreases. Got it?
Sir.
Another case, another case, for example, for endothermic reaction. So when temperature is increased, then it is well and good. This is an endothermic reaction. So this is very good for this. So forward reaction will increase. Because they want heat for the reaction, and already we have increased the temperature, okay. So likewise in this K will increase. How? Let's see. K is like concentration of B upon A. So since forward reaction has been increased, concentration A has been decreased. That is why equilibrium constant has been increased. Got it? Please let me know.
Yes, sir.
Please copy it down. From where you have to copy? From here. Have you copied this?
Yes, sir.
Have you copied this part?
Yes, sir.
Yes, sir.
Please do. Uh, please copy later. Let's solve this question after understanding this concept. You have to describe the equation is given is 2H2 plus CO is is in equilibrium with CH3OH. Please apply your concepts which I have told you. So you have to comment, describe the effect of what? First one is addition of H2. Okay. Addition of CH3OH. Another one is removal of CO, carbon monoxide. Okay. See, in this reaction, in first case, we are adding H2. Hydrogen is added in the reaction. So as you can see, more hydrogen is added. The concentration of hydrogen has been increased. So it will try to decrease the concentration of hydrogen here. That is why more and more reaction will happen in this case, and it will move in this direction, so that this concentration will also increase, and thus equilibrium is achieved again. Are you getting this? Hello,
Yes, sir.
are you getting this point?
Yes, sir.
Everyone.
Yes, sir.
Let's see with the example of this one, addition of CH3OH. So we have added more CH3OH. Okay, so concentration of this has been increased. So obviously this is a product. The reactants concentration should also increase, so that the equilibrium can be achieved again. So the reaction will move in this direction. Understood? बोलो भाई हाँ या ना? Understood or
Yes.
not?
Yes.
Let's see the removal of carbon monoxide. So what we are doing, we are removing this. Okay, so if you remove this part, so more and more CH3OH will react with itself and try to compensate this reactants. So obviously this will compensate. So obviously this will also move in backward direction reaction. Got this?
Yes, sir.
So hope this effect is clear for you people. Anna,
Yes, sir.
if you have to note something, please note it down. After noting down, you can leave the class, and please do your homework. This question is given in your assignment also. I will give you some other questions as well from NCERT, and then next topic it will after this topic, ionic equilibrium will start. So after copying these things, you can leave the class. Thank you.
Thank you, sir.
Thanks.